Welcome to the video notes for lesson 10-3, a sequence of rigid motions followed by a dilation. This begins on page 15 in your notes packet. The learning target for this lesson: I can determine if figures are similar using a sequence of rigid motions. Remember, what we're doing here is when we do a sequence, we're doing more than one. And I also want to point out, we're not actually going to be determining if the figures are similar, because they are. What we're going to do is see what happens, or how we're basically going to practice doing more than one transformation. And with the examples that you're going to see, we'll be doing some of the previous transformations, like a translation or a reflection, with a dilation. The first thing we're going to talk about, though, is, does a given translation followed by a given dilation always map a figure to the same image as that same dilation followed by that same translation? I know that's a lot to understand. What are they asking you? We are basically trying to decide is, does order matter? Does the order that you do your transformations matter? Alright, so we're going to be doing more than one. Basically, we're going to be doing two. This is going to take a little bit to do these examples on page 15. So if you fall behind, pause the video, catch up, and then hit play. Alright, so first we're going to translate triangle ABC using this rule, x plus 3 and y plus 2. That's the first one. And followed by a dilation with a center at 0, 0, which we always do, and a scale factor of 2. So that's the second transformation that's happening. Alright, so we're going to split our workspace in half. So draw a line down the middle. One side is the first, the other side is the second. Actually, that's already there, so I'll just leave it. Alright, so first thing I need to do is identify my 3 points, A, B, and C. So when I look on the graph, A is at -5, 1. B is at 0, -3. And C is at -5, -3. Alright, so we are going to first do the dilation, or excuse me, translation, the slide. And we're going to add 3 to the x-coordinate, so -5 plus 3, so if you want to write that up above just so you know what's going on. -5 plus 3 is -2, and this is A prime. We are going to label, because we're doing two different types, we're going to label prime and then double prime. So, and then the y value, we're going to add 2. So 1 plus 2 is 3. B prime, again, we're going to add 3 to the x value. So 0 plus 3 is 3. And -3 plus 2 is -1. And then the last one, -5 plus 3, we already know, so C prime, is -2. And then -3 plus 2, we already know, is -1. Alright, so now plot those points. So we have -2, 3, that's here. We have 3, -1. And then we have -2, -1. Label them, A prime, B prime, C prime. Remember, here's our original figure. So connect these points. Well, that wasn't a very straight line, neither was that. This is our first transformation. Alright, now we're going to use blue. If you have different colored pencils, this would be a great time to use them. A prime is -2, 3. We are going to dilate with a scale factor of 2, so we're going to double this. So A double prime, negative 2 times 2 is negative 4. 3 times 2 is 6. So negative 4, 6, and that's our A double prime. Oops. B prime is 3, negative 1. I'm taking that right from here. And I'm going to double those values to get my B double prime. And I get 3 times 2 is 6. Negative 1 times 2 is negative 2. So I have 6, negative 2. And that's right here. This is B double prime. And then the last one, C prime, is negative 2, negative 1. C double prime is negative 4, negative 2. And that is right here, right in the middle of. So this is going to be kind of tricky to see. So that's why it's important to use a different color or a highlighter or something if you have it. Alright, so my original image translated here and made a congruent figure. Then we dilated it, enlarged it, and created our third image, or second image, I'm sorry. And it is obviously similar because it's larger than the original and the pre-image. Alright, so let's see what happens. I'm going to clear the screen, so pause it if you need to copy this down. Let's see what happens if we change the order that we do this. So this time, we're going to do the same. We're going to do the same transformations, a dilation with a scale factor of 2, but this time that's going to be first. And then a translation, that's x plus 3, y plus 3, that's going to be the second. So there's two things happening, so I split my workspace in half. First one, let me first mark this as the original. Alright, so first I'm going to dilate. So again, my A, B, and C are at negative 5, comma 1. B was at 0, negative 3. If you're wondering, I mean, you can look on the graph or you can look up above. It's the same A, B, C that we started with. And negative 5, negative 3. Alright, so this time we're dilating first. So A prime is going to be this point doubled. So negative 5 doubled is negative 10. 1 doubled is 2. So negative 10, 2 is here. And that is my A prime. B prime is going to be at 0, negative 6. So 0 down 6, there's B prime. And then C prime is at negative 10. And then negative 3 doubled is negative 6. So all the way over here. C prime. Connect those. Now obviously this is not a congruent figure. This first transformation changes the size, so it enlarged it. Now the second one, we're going to take all these points, so A prime, which is negative 10, 2, and we're going to add 3 to the x value. So A double prime, negative 10 plus 3 is negative 7, and then 2 plus 2 is 4. So A double prime is negative 7, which is in between negative 6 and negative 8. Up 4, put a dot. There's A double prime. B prime is at 0, negative 6. B double prime, we are going to add 3 to 0, so that's 3. We're going to add 2 to negative 6, that's negative 4. So 3, negative 4. That's right here. This is B double prime. And then C prime is negative 10, negative 6. Oops. We're going to do C double prime, we're going to add 3 to negative 10, which we already know is negative 7. Add 2 to negative 6, we already know is negative 4. So negative 7, negative 4, that's right here, right in the middle of the first one. C double prime. Connect your points. Again, not a bad idea to have some different colors here, because as you can see, everything's getting a little messy. Alright, so this time we had 2 images that are the larger size. The previous one, if I go back, we had 2 figures that were the smaller. So, let's go back to the original question. Does order matter? I should have put a question mark there. And the answer is yes, the order does matter. The order does matter when you are doing a dilation. And remember, in the previous unit, so write this down at the bottom. Yes, order matters. In the previous unit, a lot of times, if we did a reflection and then a translation, we could do the translation first and then the reflection, and it didn't matter. This time it does. Alright, page 16. We'll do this first one together. It's again the same thing. I realize the X here got a little lost. It's supposed to be down here next to the X-axis, and the Y is a little off too. Don't worry about that. Reflect BAM over the Y-axis, followed by a dilate. So first thing is going to be a reflection over the Y-axis, so there's first. The second thing is going to be a dilation with a scale factor of 3. Alright, so divide the workspace in half. First we're going to identify, alright, so we've got first task, second task. So we're doing reflection first. Now, I know the rule, but I want to make sure you know it. So first, the coordinates of B for BAM is 2, 4. This point here is 2, 4. If I reflect it over the y-axis, B prime is right here. What are its coordinates? Negative 2, 4. Now, if you look at what happened, the x value became the opposite, the y value stayed the same. So let's do that for the rest of these. So A is at 1, 1. So that means A prime is going to be at negative 1, 1. And that's right here. A prime. Oh, don't forget this is our original. And then C, oops, not C, sorry. C used to A, B, C. M, for BAM, is at 3, 2. So if I make the opposite of the x value, M prime is negative 3, 2. And that's right here. Connect your points, make sure all of them are labeled, all your vertices. M prime. Alright, so now we're going to do the dilation with a scale factor of 3. So since it's a larger number, it's going to be an enlargement. B prime is at negative 2, 4. And if I triple those, B double prime, so negative 2 times 3 is negative 6. 4 times 3 is 12. So you can probably tell now why this grid was kind of rearranged the way that it is, so we could fit this point. Negative 6, 12 is all the way up here, and that's B double prime. Oh, let me go back. Put a 1 inside this one, by the way. A prime is negative 1, 1. So A double prime is negative 3, 3. Remember, I'm tripling it, I'm multiplying it by 3. So negative 3, 3 is my A double prime. And then C prime is negative 3, 2. So C double prime is negative 9, 6. So I'll go back to negative 9, up 6, 4, 5, 6. Put a point, C double prime. Connect your vertices, your points. And no, I realize my lines are not straight. You can do a better job than I did. Alright, so there's one more on this page that I want you to try on your own. It's a rotation first, so that one's going to be a little tricky. You will have to turn your paper 90 degrees counterclockwise. I want you to try this on your own. It's okay if you get it wrong. I just want to see how many of you are willing to try it. So first thing is going to be a rotation. And then the second thing will be a dilation with a scale factor 1/2. So remember, when you multiply by a fraction or decimal, you end up with a smaller number. So it should be a reduction. Alright, that's it for this video. If you had any trouble or if you didn't get something written down, go back and rewatch it, hit pause so you can copy everything down, ask questions if you still don't understand. Good luck, and we'll see you in math.